I'm Dhiraj Mahapatro. I'm a principal serverless specialist SA. I focus on financial services customers. And this topic has something that has come up really well when it comes to financial services. And then I met Uma working on the same topic as well. So I'll let Uma introduce.
Hey everyone, Ramadoss. I'm also a solutions architect at AWS. I focus on serverless. Nice to meet you all today.
Thank you, Uma. So this is something that we both are passionate about, talking about how serverless and event-driven patterns can be applied to generative AI. With that, let's look at what our agenda will be today. Well, GenAI or generative AI in general is, how many of you have heard about GenAI? Almost everybody, right? It's not new. It is like constantly. It's like if you're walking, you'll hear, hey, foundation model, generative AI. So you'll be listening to those terms more often. So we'll give a brief introduction. We'll not dive deeper. We'll talk about what generative AI is and how that fits into industry use cases. And then look at where serverless and event-driven patterns can help for you to build generative AI applications. And then overall, we'll see the bigger picture, like spanning out, we'll see the bigger picture, how all of these things can be stitched together. Okay, with that, okay. The most common and the most foundational part of generative AI, no pun intended, it's called foundation models, right? So what are foundation models? Foundation models, as part of generative AI, they have nothing new, but we have done it already. Usually models were built from scratch, but foundation models has already been trained and built on a vast majority of data. So that's what you get when you do generative AI with foundation models. In general, generative AI, with Gen AI, you can create, and I'll use the word Gen AI instead of generative AI because I can save some time. With Gen AI, you can create new contents, you can create new images, you can create new videos, and you can do a lot of stuff. And all of that is powered by large models. And the reason it has become so popular is because it's pre-trained. You don't have your data science team go and train them based on data. They're already trained, so you can very well go there and directly use them, right? For example, it can learn English vocabulary and create a poem for you. So you can just give two texts and say, write a poem for step functions and event bridge, and I will get a poem on step functions and event bridge. So that is what power of generative AI is. The core of generative AI or foundation models is how you deal with texts. LLMs are large language models. Large language models are trained on text, and they are the subset of all foundation models that we see today. So what LLMs can be used to produce those text contents, and you can make more use of those text contents. You can take that output as input to a new prompt or new content, and you can go keep on working on them, and you can build something very new and very drastic that is totally different from what you had earlier. So the core part of using a generative AI or large language models is something called prompts. So think of a kid. So you have an intelligent kid who knows everything about the internet, everything about the world. But you have to ask the kid the right question in the right way. That's what prompts are. When you talk about prompts, we have to engineer prompts to make sure that these prompts are available for LLMs or large language models. And with those prompts, you can go ahead and get your work done. Some of the examples, like write a poem on music and Nashville. You can get a good poem out of your LLMs or any text-based models. You can even ask LLMs to create code for you. Like if you can ask, give me a Python code using GOTO 3 client, or just give me a Python code which uploads objects to S3. Those things are possible. Now there are other ways as well. You can ask LLMs to provide you text. And in that case, you have to train them. You have to like, hey kid, hold on, listen to me. This is how it should work. Can you give me a new output that looks like this? So one example is you can provide some context and say, I have these many tweets and these are the sentiments. can you go and figure out the sentiment for the last tweet, which is the new hot chicken restaurant in Nashville was incredible, right? So the one we saw earlier is termed as zero-shot prompting. You did not provide any context to that LLM, and the LLM was able to provide you an answer. So there was no shot from your side, so it's a zero shot. But in the next category, we had few shots. We had to provide some context. We have to provide some training to the LLM to provide a expected output. So that's called few shot prompting. There are many more. We have fine tuning as well, but we're not going to touch on fine tuning. But keep in mind, prompt engineering is something very critical. The more you become very intuitive and more sophisticated in writing prompts, the better you will see outputs coming from LLMs. On AWS, you can access foundation models two ways. One, we recently made Amazon Bedrock generally available, which is serverless, and it's the most fastest and easiest way for you to build a GenAI application, right? So you can go to Amazon Bedrock console, you can say, write a poem on Nashville and music, and Bedrock will give you a response. On top of that, there is a button in Bedrock console where you can click and see how the API call would look like. What should be my JSON data if I have to make the same question via an API call? So it's very intuitive. It's fully serverless. The other form where you can use foundation models, and before Bedrock we have been using this more often, was using SageMaker Jumpstart. With Amazon SageMaker Jumpstart, you can get third-party models. You can get the models that are already available in Bedrock as well. You have to bring them up in a cluster and an instance and make them available for inference, right? So there are dedicated instances or computing that is available that you can use, and you can make it up and running and use the same way. When you do an inferencing, you can use the same way like you did with Bedrock. Let's look at some industry use cases. Now that you have known about foundation models, LLMs, what is Amazon Bedrock, prompts, SageMaker Jumpstarts, where do we apply this, right? That's the most common question you will see. Some of the use cases include, it's not limited to these ones, but the major ones which I have seen, which Uma and we have seen, is like, when you think about HCLS, like healthcare life sciences, we have medical transcriptions, which are scattered across multiple areas, multiple documents. It can be a recording, it can be an audio, it can be a PDF document. They're all scattered across and stored somewhere which is not accessible, not searchable. With LLMs or with generative AI, you can gather them, you can summarize them, and you can make them available in a very comprehensive way to medical professionals like doctors and nurses, so that with few clicks or few minutes, they will be able to get the entire details of a case if they're working on, if they're training on how should I do this surgery. Have we seen these cases earlier? You can summarize those kind of data and make them available readily. So it will save valuable time for medical professionals. Other one which I'm very closely working with right now is insurance claims documents. So think of a property and casualty insurance. It doesn't limit to property and casualty. If you have any insurance, or if you're any insurance provider, when any claims that is filed, whether it's a car claim or a life insurance claim or any device insurance claim, whatever claim is filed, you can do some, as an insurance provider, you can do some additional checks to figure out whether the data that was provided as an image has any anomalies, has any fraud, or you can, based on that summary of the report, you can move forward and see what, based on that context of data, contextual data, you can see what should be the next step. How should I move forward and deal with this claim process? So that's a good benefit of generative AI. Here is a QR code which leads you to a blog, which I wrote with the AI/ML team at AWS. It talks about intelligent document processing using generative AI. The next use case is pretty common. You'll see more common because this is mainly related to one of the major GenAI use cases, which is chatbots or Q&A, question and answer. Think of a case where you have a customer service agent in your organization and they are on call with your customers, right? How can you feed actual and valuable data back to the agent so that the next question the agent asks to the customer can be much more useful to the customer? So if you have a customer on call and you transcribe that voice and feed that to a foundation model, and foundation model will give back set of questions. Hey, agent, go and ask this question because it makes more sense to ask it right now. Then the agent picks it up and asks the question while on call. So in this case, foundation models or GenAI acts as an assistant for the service agent. Last but not the least, this is one of my favorite because market content generation is going to be very common with GenAI. Our marketing team or your marketing team in organizations, they work a lot to figure out how content should be, like images and videos. But now with generative AI, you can tell them, you don't have to build images from scratch, just provide the valuable text. And we have models like Stable Diffusion, Midjourney, and DALL-E who can create images for you. And we can refine that image if required. So it will save a lot of time and a lot of money. Okay? So one major question, why use serverless with generative AI, right? So foundation model can coherently respond to prompts on subject that haven't been explicitly trained on. But there are many challenges to using foundation models. And one of the challenges is how do you build an application that sits behind or sits in front of the foundation model that actually works as your business logic, right? So foundation models are generally stateless. So if you ask a question, 2 minutes later, if you ask another question related to the previous one, if you follow a zero-shot prompting, it won't understand what you're asking for. So what you have to do is build a capability right in front of those models to make sure that when you ask a question, it has a context to reply you back based on whatever you asked earlier. So you have to build some context awareness. You have to build some smart prompting. You have to build a lot of other use cases which will need actual application code or orchestration of some code, and some business logic has to live behind. That's where you think about serverless, because with serverless, you get the power of services like Lambda functions, ECS Fargate, Event Bridge, API Gateway, SQS, SNS, etc. And then they can directly work with the power of generative AI that is given by services like Amazon Bedrock, SageMaker Jumpstart, and you can do all of that while writing code which is being driven by Amazon Code Whisperer, which is our generative AI solution to write code for you. So with that combination, you should be able to rapidly deliver smarter applications and innovate faster. So to summarize the benefits of serverless architecture around GenAI, we know that serverless architecture can handle spike of traffic. It can scale up and down in relatively less time. So if you have requirements where it has to scale up and down based on generative AI requests, so serverless would be a good fit. The most important one to look at is generative AI or the foundation models. They are pretty new. The market is pretty new. So which means it is still evolving. It is still shaping up. So you cannot go and get one model to run in production for n number of days, because the model will keep on growing. The number of parameters of that model will keep on growing. And there will be a requirement for you to shift from model A to model B. So with serverless application, you'll have the flexibility to change the specifications and move to a new model. Again, with serverless, you'll save on cost and you enable integration with different services. So this is one of the biggest example of a greenfield application, because GenAI is greenfield by itself, where serverless fits best. Because when we think about serverless and you're building something new, you would ideally think of going serverless first. And GenAI is new, so it immediately fits in to become serverless first. And at the result of that is that you can build capabilities faster. Now I'll go through some of the services which you have already heard earlier in the rest of the day before. But at the core, of a serverless service in Amazon or in AWS is Lambda functions. I think everybody knows here Lambda functions with a show of hand, how it works. So it's actually a business code that you can write as a function. Any event that comes in can trigger a Lambda function, and the most critical part is you can integrate that with other services, be it S3, DynamoDB, or a foundation model. So ECS, and then, Lambda function. And then we have Fargate on Amazon ECS. If you have built container application and you want to run them on a container orchestrator, then you would not get a better combination of AWS Fargate running on Amazon ECS. You don't have any container host to upgrade, you don't have cluster capacity management, and it's fully serverless. The beauty of this combination is that you get to play with Spot instances and Graviton. So when you are considering using compute with ECS Fargate and Amazon ECS, those are the options that will help you a lot. Then, as normal, you would need an API gateway to have any communication with an outside world. So we have Amazon API gateway that interacts with various services like Lambda functions, public HTTP endpoints, and different other services. I think we heard about EventBridge a lot today, but I'll just recap on this one. EventBridge provides you a mechanism as an event router, which decouples producers from consumers. And basically with EventBridge, you have event sources, which can be AWS services or your custom events, or it can come from any partners. And then you have a bunch of bus that you can define. That can be a custom event bus, or you can use the default event bus. Or for partner, you have partner event bus. The main power of EventBridge comes when you define a rule where you have embedded business logic, and that rule defines which target to hit. So that's there, your EventBridge. SQS is also an important service when you think about running at scale with serverless, right? When a traffic spikes up, you don't want to overwhelm downstream systems like the Lambda function or the foundation model endpoint. What you need is a buffering mechanism or event store that acts as a buffer so that you can get all those traffic spikes converted to events, and then your downstream Lambda functions or your downstream step functions can poll messages at their own pace and start working on them without affecting the foundation model. So heavily encouraged to use SQS as a queue when you are building applications. And we'll learn more from Uma going forward. Last but not the least, this is Uma's favorite service. Serverless state machines can be built with AWS step functions. You can build, we learned from different sessions today, like you can build resilient workflow automation. And if you have attended Uma's previous sessions, he talked about, Adam and Uma talked about how can you do error handling with step functions? How can you integrate with other services without writing Lambda functions? That's called AWS SDK integration. And the cool part is you get auditable history of all of your executions. The best part, on top of the cool part, is that all of this is written as a JSON or a YAML file. You don't have to learn a new language. So with that, I hand it over to Uma to dive deeper on some of the patterns.
Thank you, Dhiraj. I'm going to cover some of the serverless patterns that you can use in generative AI solutions. And these patterns, for some of you who are familiar with serverless, are not going to be new. These are foundational components for any serverless applications. And so here, the QR code there, if you scan it, you will see some of the serverless patterns for generative AI solutions. We're adding patterns every day, so you might want to check out often. Majority of the use cases that we are seeing around generative AI applications is consuming the foundation model. So I will first cover the patterns that related to consumption of the foundation model. I will use chatbot as an example to illustrate the patterns, but the applicability of the patterns goes beyond chatbots. They said anything that you ask of a model is prompt. So when you build a chatbot application, you ask your user to give a question, but most of the time that same question doesn't go to the model as such. you add some enhancements, few shot prompting. So something like that you would do. So I asked this chatbot, write about music in Nashville, and I had a simple.
Nope. Back.
Sorry.
Yep.
So I had a simple prompt template. I used it for Anthropic model, a human, and then input and assist, and it gave me a beautiful answer. If, as a backend developer, if you go about build an API for it, you could use a synchronous pattern. Very simple pattern. We have already we've all used it. Have an API gateway, expose an API, and a Lambda function as an intermediary, and call a foundation model. The foundation model, it could be hosted in your, and it could be Amazon Bedrock, or it could be in Amazon SageMaker, Jumpstart, or it could be something that you have deployed in your own compute like EKS. Most of the time, you don't expose your model publicly to everybody, so you do need an intermediary like a Lambda function. But Lambda is not just an intermediary. There are two other important functionalities here. One is prompt enhancement that you saw earlier. You don't send this input right away to the foundation model. You enhance that input. Sometimes you might add instruction like, do not send sensitive information in the answer. Then the next one is the model abstraction. You are abstracting the foundation model from your front end. The models comes and go every day. When you find a more performant model, you need a way to quickly swap it out. With Lambda function, you can make little code change and then swap that model out. Any user interface requires a sophisticated authentication and authorization. That's why we chose API Gateway. And API Gateway also offers several other capabilities. Two of the capabilities that I would highlight, especially useful for generative AI solutions, is caching. You don't want your model to be inundated with repeated questions. You can enable caching at API Gateway level. And when a repeated question comes up, API Gateway answers with the answer from caching. And then API Gateway also offers fine-grained rate limiting with usage plans and API gateways. Sorry, usage plans and API keys. So let's say your chatbot has increased in popularity and more users are using. And as more users using, there's more volume of traffic comes in. Would you use the same synchronous pattern? You can, but it can result in poor performance or poor user experience. The main reason is we are right now talking about a highly scalable serverless services and low scaling a foundation endpoint. Why I'm saying low scaling? Foundation model sometimes can be hosted in a compute environment where you have lower rate limiting. The reason is it could be cost of hosting it, or it could be resource availability. So you have asymmetric scaling between the serverless services and the foundation model you're talking about. So how do we send a sustained traffic to the foundation model? That's why we use Amazon SQS. So API Gateway sends a request to Amazon SQS. Lambda function can directly consume messages from SQS. And you can also configure how many Lambda functions you can stand up to consume from SQS, which can correspond to the rate limiting on the foundation model endpoint. So in that way, you send sustained traffic to the foundation model. Now, your request became asynchronous. This is an asynchronous pattern. User sends a request, user sends a question. They get an immediate response that the question is accepted, but they don't get an answer. So how do we get a response asynchronously to the user? There are so many techniques available. The easiest one is probably sending an email when the response is available, but that may not be suitable for many use cases. One technique is polling. You can have Lambda functions store the information in a database, and then have an API available in API Gateway, so keep polling that API until the answer is available. It introduces some delays depending on the polling frequency. It is also resource wastage. Another way you could have send the response back to the user is WebSockets. two-way interactive communication between the client and the server. API Gateway offers WebSocket. AWS IoT Core offers WebSocket. And there is also AppSync subscriptions. So you can use these mechanisms to send the asynchronous response back to the user. All right, so we got a question, we got an answer. I actually did not like the format of the response that my chatbot gave me earlier. So I tried to give ask it again to change the format into bullet point. So I said, write the same in bullet points. It gave me a random answer. Dhiraj mentioned earlier, foundation models are not inherently stateful. So what can I do to make the foundation model be aware of my conversation, the previous conversation? So what I did is I asked that question, but in my prompt template, I enhanced that question. I added my context from my previous question, and I asked the model, and now it gave me the accurate answer. So now we're talking about storing that conversation context somewhere, the total conversation history, everything. So there's another familiar pattern that we've all used using database, API Gateway, Lambda, and the database. So we use DynamoDB here. You store the conversation history in DynamoDB. Now it might be very simple, but when you think about it deeper, this is not a simple thing. It's not straightforward. We're talking about conversation history, we're talking about users, sessions, tracking them, and sometimes conversation history can go really huge in like very short time. And our foundation models have request payload limits, just like every other services, and sometimes some even can go up to 1,000 tokens. So there's a technical summarization of conversation. So instead of sending the whole conversation history, I can just summarize that conversation and send a shorter information as a context, and foundation model still can give me an accurate response. But now I have to summarize, so it's not a single thing that you would write in a Lambda function. Your Lambda function now grows bigger. It's not single responsibility Lambda function anymore. So now since I have multiple steps, I choose to go with a workflow pattern. So within workflow pattern, like with step functions workflow, it's a low-code visual service. You can have all of those steps defined. For example, the structure, the sample architecture would look something like this. The first, I will check whether there's a session. And if there's a session, I grab that conversation history, or summary in this case, and then enrich that prompt. I don't really need a Lambda function to enrich the prompt. I can use step functions intrinsic function to enrich that prompt, add the conversation summary, and ask the LLM for the answer. Now LLM responds with accurate information. I will send that response back to the user asynchronously, but my workflow doesn't stop there. The reason is I've got a new information, like the new question and answer. I need to add it to the conversation summary. So then I create a conversation summary again, and then I store it in the database. There's multiple things that you need to do, and step functions is a great way to connect everything together as a single workflow, and also with less code. Now, so far we talked about invoking a single model. How about use cases where I need to invoke multiple models? For example, I'm generating a content for a marketing page, and that requires a text information as well as some images that corresponds to the text. I need to invoke a text model and also an image model. Amazon SNS and Amazon Event Bridge, where the pattern that I have is a very familiar pattern for most of you. It's a fan-out pattern. Fan-out pattern distributes messages to multiple destinations in parallel. So you can use both Amazon SNS and Event Bridge to fan out these messages. You can add rules and filters to apply the filters and choose which destination you want here. Right? So you can have like one destination, two destination, or like all the destinations fired up at the same time. So with that, our architecture now looks like this. When you're calling to a text-based model, you can go with AWS Lambda. If you need to run a workflow, for example, use cases like prompt chaining, we'll talk about prompt chaining later. You can use AWS step functions. If it is an image task, or you need a task that needs to run for more than 15 minutes, you can use AWS Fargate connected to it. Now, so far, we asked a generic question, and the model gave us generic answer. How about you ask a question that is internal knowledge, something domain-specific to the chatbot? So what I did is I asked this chatbot, what is distributed map in AWS step functions? And I also gave instructions. I do not make up an answer if you don't know, and model promptly responded that it doesn't know about it. The reason is it doesn't know. If you ask a foundation model without enabling it for domain-specific information, it is going to be either limited in its answer, or it's going to give you an erroneous answer. There are multiple techniques to make the model context-aware or domain-aware, and one of the popular techniques is retrieval-augmented generation, or knowledge retrieval. As the name indicates, you're retrieving the knowledge from a knowledge store, augment the prompt with that knowledge, so augment the question with that knowledge, and then ask the foundation model to generate the answer. And so now the prompt will contain, just like earlier in the conversation history, the prompt contains the question as well as the knowledge information. That knowledge can come from a knowledge store like Amazon Kendra, or it can be from vector database. Some of the popular vector databases are OpenSearch, Amazon OpenSearch Service, ChromaDB, and Pinecone, etc. Vector databases are specialized databases. They store numbers. And they also organize this information in a clever way, so similar informations are placed closer to each other. So if I ask a question that is domain-specific, this information in numbers should exist ahead in time. So somebody or somewhere, this process of changing this domain-specific knowledge or document, whatever it is, to be converted to a number should have happened. And that the conversion is typically done by an embedding model. It's a special kind of a model. And so it will go through a series of steps, and you will convert the domain-specific information to a number-based information and store it in a vector database. And so here, if you scan the QR code, there is a GitHub sample, which is a great one to check out. This is a LLM chatbot with RAG capability. So the step of converting a text information to a vector embedding, it involves multiple steps. So I'm going to show another workflow pattern. So you've got like list of documents, and they have to go through pre-processing, chunking. This is a very important step because you might be transforming a document which is a 100-page document. Just like the foundation model that we saw earlier, embedding models also has request payload limits. So you need to chunk them to match that payload limits. You create the embeddings, and then you store the embeddings. And so again, as a step functions workflow, you could put everything together. If you are using Amazon Bedrock, this process is actually readily available through Bedrock agents. You don't really have to go through this process. Now, if you look at this whole process of how this context-aware invocation will occur, it will start with a user uploading a domain-specific knowledge, a document, into Amazon S3. You can have an S3 event notification to trigger Amazon Event Bridge. And then the Event Bridge apply filter, and then you can call step functions workflow. And then that's where that previous slide, the workflow will happen, and we'll store the data in vector database. And then the user can ask a question related to the document that they uploaded. And that goes through the familiar path of API gateway, SQS, to Lambda function. And this time, Lambda function is not going to call the model directly. It is going to first ask the vector database to get a similar information. So it does a similarity search on the information that is stored in the vector database to the question that is asked from the user. Then it gets the context augments the prompt with that context, and then ask the foundation model for an answer. And that answer can be sent back asynchronously through the asynchronous mechanism that we talked about earlier. This whole process is retrieval augmented generation. Prompt chaining is a technique to wire multiple prompts and responses together in a sequence of workflow pattern to achieve a business process. Think about use cases like prompt chaining. Use cases like trip planner. A trip planner, let's just say if it is a generative AI-enabled agent, it can ask the traveler where they want to travel, like the location and budget, and then it can offer information like where they can stay, the hotels they can eat, and the activities they can do. And this is a series of steps they need to do. I have given here an example of how you can generate a story. In order to generate a story, the workflow first asks the LLM to generate the characters. So every story has characters, so it asks generate the characters. And that response is fed into the next step. And in that step, every single character has got an unique story, and everything comes from LLM. And you've got like characters and the character stories, and then you wire them together to create a new story. And this whole process can be enhanced by adding a human in the loop. For example, think about an editor who is looking at the story, reviewing the story, and if he doesn't like it, he can just ask the workflow to kick it off and regenerate a story. Step functions integrates really well with human approval workflow, so human in the loop can be easily embedded into the prompt chaining. Now, with that, I'm going to step aside, and Dhiraj will cover pattern related to hosting a foundation model, and also the better together story of how serverless and the generative AI solutions work together.
Thank you, Uma. So as a whole, we saw like how if you use Bedrock serverless endpoints, then you can focus mainly on writing business logic using serverless. Now, if you want to switch the attention to a little bit like towards SageMaker Jumpstart, where you have to host a model, like if you have a requirement where you need to do some documents processing or document summarization at scale on SageMaker, right? You can do that if you want to do that as a real time. As and when document comes to an S3 bucket, you can hit your SageMaker endpoint and summarize the document. However, at scale, when you run that, if you have multiple documents, you have to run that SageMaker endpoint throughout the day, and that can incur a cost based on the instance that you have used underneath. Here is a cost-effective technique where you can summarize at scale, and you can schedule document summarization with SageMaker endpoint. So think of it as if you have written some tests, you can set up in the test, you can run your test, and then you tear down. So apply the same principle here. In this state machine, I can schedule this state machine to run nightly, and I can gather 5,000 or 100,000 documents. And on demand, I can create a SageMaker endpoint config. I can create the SageMaker endpoint, and then figure out if the endpoint is available or not. And for 30 seconds or 1 minute, and I can poll and figure out. If it is available, then I can use the distributed map capability. If you've attended the previous session, distributed map is a cool feature in step functions. I would highly encourage to check that out. And you can call AWS SDK integrations, like calling text tracks directly, calling SageMaker invoke endpoint directly, and other config endpoints directly. And you can run document processing or document summarization at scale. Once you're done with that, last two steps that you see here is delete SageMaker endpoint and delete SageMaker endpoint config. So you tear down the whole setup, which means you only run the SageMaker endpoint when you need it in the night. So that will drastically reduce your cost. So you can think about those scenarios where if you have to host in SageMaker Jumpstart, you can build workflow orchestrations like this where you can save on cost. Now let's step back and look at the bigger picture. We've talked about APIs where you have uploading documents, question and answer with chatbot, text to media with things like Stable Diffusion, Midjourney, and then model evaluation, like if you have to run a query or if you ask multiple models, get back response and check the accuracy of each model. All those things are available, or you can do that on top of GenAI available in AWS. You can do text summarization, which we saw right now. In the right-hand side, we have all the models that you can use today on AWS. On the top row are all AWS services for AI/ML, where you can use Bedrock, Jumpstart, Comprehend, Textract, and all those things that will help you, enable you to run generative AI applications. And then there are tools like LangChain that you can incorporate in Lambda functions or ECS Fargate, and then you can work on it. What we saw is actually a good story of putting everything together as an event-driven architecture, right? And how is that possible? We talked about event brokers, and event brokers will facilitate highly extensible architecture. With the fan-out scenario that Uma talked about is not just 3 rules, you can have 5 different rules to figure out if you have to call a new model as part of the fan-out process. So it is highly extensible. You have queues that can handle scale without overwhelming the foundation models or the underlying compute. And then you have orchestration services like step functions, where you can run RAG or run document at scale. Then you have those ever-changing foundation models that will keep on evolving. You have to keep on changing the endpoint. You have to make them available to your business logic. Then we talked about notification systems, like how you can send responses back by polling or IoT core. The most important part that we did not talk about yet is what happens in the future. Generative AI is new. We have not thought about governance, auditability. We have not thought about analytics. EDA, event-driven architecture, will facilitate to build those systems as and when you progress with evolving your architecture. So keep that in mind. If you start with event-driven architectures, you can bring in those capabilities as and when they are asked for or as and when they are required. And finally, we saw a scheduling mechanism where you can use event-bridge schedulers to schedule a lot of documents, summarize a lot of documents at scale. So this is the entire story of how you can think about event-driven architecture using serverless services and around GenAI. We talked about a couple of services, but they are not limited to those services. You can, when it comes to API, AppSync, WebSockets and API Gateway, IoT Core. When it comes to compute, we have ECS and AWS Fargate. When it comes to router, we have Kinesis data streams, Amazon MSK, and Amazon MQ, and same with Event Store, not just SQS, but we have this plethora of services. With that, here is an example which you can scan this QR code. This is a blog that is written by David, our most beloved serverless DA. And you can scan this and you can read the blog and see how he has implemented a story generation app using ChatGPT and DALL-E. To summarize in quick few minutes, you're enabled to eliminate bottlenecks if you start using EDA. We talked about the governance part, that is the part of evolutionary architecture. So you evolve with EDA, and then you get fine-grained scaling of components, and you can extend all those features to different parts of your business. Most importantly, you have reduced the fault impact radius, because if you fail on a small component, only you fail at that component. You are not affecting other areas of your event-driven architecture. So you fail fast, you recover, and you go to market faster. There are a couple of resources that you can scan, and we'll provide you this resource, or reach out to us, and we can provide you these resources as well. Blogs and a workshop, and the LLM chat application that we showed as a QR code that will help you keep on moving and get started. With that, thank you everyone. Happy that everybody is here. Happy to be here and learn more from everybody else in this GOTO EDA day. And please give your vote for this session using the GOTO Guide app. Thanks a lot.
Thank you.
All right.